Hey, and welcome! Today, we're going to trace the incredible, kind of invisible journey that happens with every single click you make online. Let's dive in and figure out how a website gets from some server somewhere in the world right to your screen.
I mean, it really does feel like magic, doesn't it? You type in a web address, hit enter, and poof, the page is just there. But it's not magic. It's this unbelievably fast and honestly pretty complex system of addressing and delivery. And that's what we're going to do today. We're going to trace that exact path from your screen out into the world and all the way back again.
So, it all starts with this, a single click. The second your browser sends out a request for a web page, you've kicked off this massive chain reaction. Think about it. That simple request has to find one specific server, maybe thousands of miles away, grab the info, and haul it all the way back. So, how in the world does it know where to go? Well, it's kind of like sending a letter, right? Your digital message needs an address, but here's the twist. It actually needs 3 different kinds of addresses. This is to make sure it gets to not just the right building, but like the right person sitting at the right desk inside that building. Yeah, you need these different addresses for different parts of the trip. You've got the IP address, which is for the big global part of the journey, getting it to the right computer network anywhere in the world. Then there's the MAC address. That's for the super local delivery, finding the exact device. And finally, the port address, which makes sure the message gets to the right piece of software on that device. Let's break them down. Okay, first up, the IP address, the Internet Protocol address. This is the big one, the one most people have heard of. It basically tells the rest of the internet what country and what city the destination computer is in. It gets you to the right neighborhood, so to speak. All right, so the IP address got your data to the right neighborhood, your office Wi-Fi, your home network, whatever. But now it needs to find the exact house on the street. And that's where the MAC address comes in. The Media Access Control address is the unique physical street address for your device's network card. And look at this, you can actually see it. The MAC address isn't just a number in the software, it's physically burned into the network card itself. It's like a serial number that never changes. This is what makes sure that on your home Wi-Fi, the data for your laptop goes to your laptop and not your smart TV. No confusion. Okay, so we found the right city with the IP address, the right house with the MAC address, but what about the person inside? Your computer is running a ton of different programs at once, right? The port address is the final piece of the puzzle. It's like the apartment number. It tells the computer which specific application, your web browser, your email, your game, this data is actually for. I love this cartoon because it shows this perfectly. The data packet arrives at the computer and it's basically shouting, "Hey, I've got a delivery for port 80. The web server, which is listening on port 80, says, "Yep, that's me," and takes the package. Meanwhile, the email server over on port 25 just ignores it completely. It's a super efficient way of sorting the mail. All right, so we've got the addresses figured out, but how does the data actually get packaged up for its long journey? Well, it gets wrapped up using a set of rules or protocols called TCP/IP. You can think of this whole system as like a digital packaging department. See, sending something over the internet isn't just one single action. It happens in layers. Your request for a web page, it starts at the very top layer, and then it travels down through the other layers. And at each step, it's like a new wrapper is added to the package, each one containing important info for the trip. So here's how that whole packaging process works. First, at the application layer, your browser creates the actual request. Hey, give me this web page. Then it moves down to the transport layer, which slaps on the port number. Next, the internet layer adds the big one, the destination IP address. And finally, the link layer adds the MAC address for the very next stop on the journey. And just like that, our little package is fully addressed and ready to go. So our little data packet is perfectly addressed, perfectly packaged, and ready to roll. But how does it actually leave the building? How does it get from your computer out of your house and onto the massive data highways of the internet? And this is a really, really important point. Inside your local network, your home, your office, all the devices talk to each other using those physical MAC addresses. It's like sending mail within one office building. But the second a message needs to go to a different city, it has to switch over and start using the big global IP addresses. Yeah, this diagram nails it. See how inside LAN A, all the communication is happening with MAC addresses? But look, the moment a packet needs to jump over to LAN B, it has to travel across the internet. And to do that, it switches to using IP addresses. So what's the piece of hardware that handles that switch? That's the job of your router. That little box is the gatekeeper, the traffic director for your entire local network. It stands at the exit, looks at the destination IP address on every outgoing package, and says, okay, you need to go this way. It figures out the best path to send your data on its way. Okay, we're so close. Our data has its address, it's all packaged up, and the router has sent it on its way. But there's one last crucial choice that was made way back at the beginning. What kind of shipping method are we using? Do we need guaranteed signed-for delivery? Or is it okay to just kind of toss it in the mail and hope it gets there?
So this decision gets made back at that transport layer. For things like loading a web page or sending an email, where every single piece has to be there and in the right order, the system uses TCP. It's super reliable because it checks to make sure everything arrived. But for things like video streaming or online gaming, raw speed is what matters most. That's where UDP comes in. It's way faster because it just fires the data off, what they call best effort delivery. You know when you're on a video call and it glitches or gets pixelated for a second? That's UDP, prioritizing speed over a perfect picture that would have arrived too late.
This is such a great way to picture how TCP works. It's basically like registered mail. The data arrives, and the computer on the other end has to send a little acknowledgement message back, basically saying, yep, got it, thanks. If the first computer doesn't get that confirmation, it just sends the data again. It's a system that absolutely guarantees nothing gets lost.
So let's just recap for a second, because this is wild. That one single click you made sets off this lightning-fast journey. Your request gets 3 different addresses, gets packaged in 4 different layers, gets shot out onto the internet by your router, and gets sent with a guaranteed delivery service called TCP. And all of that is just to find the server, which then has to do that entire incredible process in reverse to send the web page back to you.
And the craziest part? The whole round trip happens in the blink of an eye. It's just a staggering feat of engineering that keeps our entire world connected. It really makes you wonder, right? As this invisible, lightning-fast system gets even faster, even more seamless, what's that going to make possible for our future? What's the next step in the journey of a click? Thanks so much for joining me.